Hello, I am Asmae Khaldoun from Akhawayn University in Morocco. I am presenting today our work on bioclimatic materials and construction practices done in the framework of the Africa-Europe Bioclimatic Building for the 21st century. According to the International Agency of Energy, 38% of the total global energy-related CO2 emission in 2020 is generated from building activities. So, to solve this problem, we thought about designing this kind of bioclimatic building that are energy efficient and also offering comfortable and healthy environments. We we build our projects on the long history that Europe and Africa has on construction, on constructions, on for example, on earth construction and bioclimatic constructions. And therefore, there is an accumulated experience of thousands of years. However, a notable switch to concrete-based construction can be observed in overall the world. This is leading to a loss of expertise in the field, loss of local jobs, and increase of green gases and CO2 emission. We'll give in this project a special interest to design strategies that involved local bioclimatic approaches. We will reduce energy consumption during material manufacturing, building construction, and energy demand for cooling and also heating. But mainly here, we are focusing in arid region and arid climate. So we speak mainly about reducing the energy for cooling because we observe that the temperature in worldwide is increasing. So these solutions, of course, exist. Some of them already exist. I need just to be disseminated because some experiences are just locally known, and some of them need also to be adapted to different kind of regions, and also some of them need to be developed more and introduce more technology to make it more suitable for our modern life. So we can get also some inspiration from the nature, like for example, the Saharan silver ants that is using the daytime radiative cooling, which is because it has this reflective skin that can keep her body very cool, even in very, very arid and hot environments. For this, a consortium of scientists and engineers working from Africa and Europe are working together to find solutions to this kind of buildings. The first task was to make like a review of infrastructure for production of local construction materials in North and West Africa and Europe, because as we said, there are plenty of experiences that already exist, need just to be like disseminated. So this is why we made like a kind of table that you can see here, where we gathered most of the companies active in the production of bioclimatic materials and the ones that are making like projects and constructions. So in this table, you found the name of the company, the contact, the activity, and also the past projects. Of course, all these companies are also divided in terms of the country of origin. In our second work package, we made an intensive review and analysis of materials and construction practices, the ones that are local and or adapted to local conditions. So, of course, the bioclimatic materials studied are mainly first the ones are earth-based construction, like the clay construction. So, in this kind of earth-based constructions, you found the adobe. You can also have the bricks, the clay, amphite clay bricks, of course, with additives, and also we see like the effects of additives. We have also several articles related to this part. You also found the rammed earth and earth-backed constructions. So in this kind, we were amazed to find very interesting projects that are really very modern, that can use this kind of traditional constructions with some modern touch. You have also, so we also have, we gathered like the industrial and also a lot of research that are in the field. You found also the stone construction that is like existing for a long time and still very modern and very useful. We found the cork-based bricks, the handcrete. You have the straw bale constructions. You have also this kind of material for construction and also for insulation. So you have the thatched roof, you have the Taifa-based bricks, you have the wood, the bamboo, and the wool. So these are all very interesting type of materials that are some are from natural, like all natural, some from animal source, from plants, and also from like earth. So the methodology that we followed during this study, so we looked for the material. So we see the properties, means when we speak about the properties, we'll speak about first the composition, the chemical properties, like the composition. Then we studied and gathered all information about the mechanical properties, for example, the compressive strength, so the water absorption, so all kind of porosity, all kind of information that are very relevant for construction. So all the properties, like mean the chemical, physical, and mechanical properties are analyzed. Then we, for each type of material, we see the obtainment process and also the construction practices and method for application. Then we gave a cost assessment for bioclimatic constructions, and then regulations for bioclimatic construction and material, which is a very interesting part because there is a lack of regulations regarding this kind of type of construction. As you can see here, there are plenty of ways to use earth or clay for construction. We use it as the adobe for as that was used for a long time and still used in the rural region in Africa. You have the clay bricks. So these clay bricks can be fired or unfired, and amazingly when adding additives. So we do a lot of research on this field. So adding additives adds, normally when you add additive, what happens? Normally you can improve the thermal properties and also the density. You make the brick less heavy, but the problem that you lose on mechanical properties. But what we found is that when you add a proportion of an additive that is quite low, for example, you don't exceed the 2% of the additive, generally, you will have you improve the thermal properties and the mechanical properties of the bricks. So sometimes in many conditions, you can have bearing walls just with unfired clay bricks. So which is very interesting. We can see this very amazing rammed earth constructions. So you can see here that it's very appealing, this kind of constructions. You see villas and made just with the rammed earth, where you have two type of, like for example, you have two wooden parts that blocks the earth, and then by compression they compress several layers of the clay, so you can have this nice construction. We can also speak about the Nubian vault technique, which is a very interesting technique that is using the idea of the chain or the idea of the arcs. That's because this is the strongest type of construction. If you use just like adobe kind of bricks, you can use the Nubian vault and you can have very good constructions. We can also speak about, and we found very interesting type of construction, which is what we call the earth-backed constructions. Many activities now are done with this, or construction are done using this kind of techniques, and you can see even very modern and fancy kind of constructions can be done using these constructions. When we speak about the properties, we can speak, for example, about unfired clay bricks. Why we are interested to unfired clay bricks? Of course, because reducing the firing process, because usually when you fire the bricks, you need to reach a temperature of 8 to 9 to 1100 degrees Celsius. So now with unfired clay bricks, we don't use any firing, and you just add some additive at a given proportions to have very good properties. So you can also speak about the straw. You have the natural additive, like for example also the taifa, which is a very, very interesting kind of additive and can be also used as also compressed bricks. So when we look to the materials that we used, for example, if we compare the three types, for example, you speak about unfired clay bricks, you have the unstabilized rammed earth and the earth bags. The compressive strength can vary and can reach, for example, for unfired clay bricks, for example, with additives, it can reach even a high, very high value exceeding the 8 and the 10 megapascal. So we can see that for unfired clay bricks, we can have interesting compressive strength and in the same time, very good thermal properties. So we can also speak about other type of construction materials like the cork, the hempcrete, and the papercrete. So there are all kind of construction material. You can see that they have some compressive strength that is also relatively interesting. So they can also have reach like almost 3 for the cork. And most of this kind of material are mainly used for as insulation material. As I said before, stone is a very interesting material, and their property will depend on their origin. So, for example, the stones that are volcanic stones will be different from the sedimentary or metamorphic stones. So you can see that their compressive strengths are very important. So this is why they can be used for very safely for as bearing walls. They have their thermal conductivity will depend on their origin. Mainly volcanic rocks will have less thermal conductivity. So we saw also different type of constructions. You can see here the straw ball construction, where you can have like some frames from wood, and you have like ball the straw that is like stapled on the top of each other. So this is of course a very interesting material because it offers a very good comfort inside the houses, and you can see here that their thermal conductivity is very, very low, which make it very interesting as a construction material. So here we gathered, like if we compare all these materials in terms of their mechanical properties, we can see that the stones have the best like mechanical properties, but the unfired clay bricks with additive can have interesting like properties because they are close, for example, to 10, which is interesting in many applications. And when we don't go to different like building with the high building, I would say, tall building, I would say. So here you can see also a difference. So you can have here the papercrete, the hempcrete, the cork, the block, and the rammed earth that have also interesting like physical property that can make them also suitable for different application. So here we can see that it's very interesting to use the right material in the right location. For example, for 2 first stories, it will be fine to use the clay. For more, you can also use other type of construction material. Here we can speak about the thermal conductivity. As we can see here, that the thermal conductivity can differ from a material to another, and also from in each type. For example, for stone, you see like a big range of difference between the different type of stones. So this will depend on the origin, as we said before. So we have the unfired clay bricks stay having very good thermal conductivity and also good compressive strength. And also for other, you can see here the different type of so straw ball have very, very interesting thermal conductivity if we use them as construction or as insulation. You can see also here the cheap wool are also very important. So here I will thank you. So there are also other, so we gathered a lot of information on this project about bioclimatic constructions. So I invite you to read the report and also read our articles on the field. Thank you very much.